In this video, we'll talk about how to calculate compound interest. This is an application of exponential functions. So down here, you can see these two formulas that are given, and you can see the little exponents, so you can see how this relates to exponential functions. It has this overall exponential shape. So first, I want to focus on this function on the left. So let's break down what all of these variables mean and what exactly this is doing. And it says here in this paragraph, but I like to write out little lists. It helps me stay organized. So capital A is our accumulated amount. And that means the principal, the initial amount that you invest, plus the interest that you earn. So principal plus interest, that's your accumulated amount. And principal, speaking of that, this capital P, principal is your initial investment amount. So if you're putting $20,000 into an investment account, P, your principal is $20,000. Lowercase r is your annual interest rate, and make sure this is as a decimal. So if a problem says you're earning 5% interest, in your formula you would put in 0.05 in decimal form. N is the number of times your interest is compounded in a year. And this one is kind of a weirdo, so we'll talk more about N in just a minute. T is the amount of time in years. So if they give you a problem where it's interest accruing over 6 months, that's half a year. So T would be 0.5, not 6. T would be 0.5 in that case. So we've got our compounding interest formula. A equals P times, in parentheses, 1 plus R divided by N, close your parentheses, raised to the power N times T. I know that's a teeny tiny little exponent up there, so N times T. And my general tip, use your parentheses. So we're going to crank these numbers out in our calculator in just a minute. Make sure you use your parentheses just like what we see in the formula. Your parentheses are above your 8 and 9 keys. Okay, so before we jump into this formula, I just want to talk a little bit about this N amount, because this is kind of the weirdo. So if your interest is compounded annually, it's compounded once a year, you would use N equals 1. If your interest is compounded semi-annually every half a year, that means it's compounded twice a year. You use N equals 2. Interest compounded quarterly, 4 quarters in a year, you use N equals 4. Interest compounded monthly, there are 12 months in a year, so you use N equals 12. And compounded daily, 365 days in a year, so you use N equals 365. If a problem goes out of its way to specify that it's a leap year, then use N equals 366, I guess. All right, so we'll talk about this compound continuously formula to the right, this PERT formula, in just a minute. For now, I'm just focusing on this formula that I boxed in purple. So in this example down here, it says find the accumulated value. So accumulated value. So we're trying to calculate A. So we want to find the accumulated value of an investment of $25,000. This is going to be our P. So our principal P equals $25,000 for 8 years. So our time frame is 8, T equals 8, at an interest rate of 3.75%. So our interest rate R, as a decimal, 0.0375. Remember, use that or move that decimal 2 places to the left, 0.0375. And then it says if the money is compounded semi-annually in question A, and then we change the compounding for B, C, and D. So N will vary across these examples, okay? So in part A, compounded semi-annually, let's go back to that chart. Semi-annually compounding, N equals 2. So we're going to use N equals 2 along with all of these values that we already came up with. So in this example, we're basically just going to type this straight into our calculator exactly as this formula is printed, okay? So I'm going to start off by typing 25,000 for P, so A equals 25,000 for P. Then I have parentheses, so above my 8 key, parentheses 1 plus 0.0375 divided by n, so divided by 2, close my parentheses, and then I'm going to raise this to the power n times t. In my calculator, this is all going to stay in the exponent, but when in doubt, use your parentheses. So we can put parentheses around the exponent. N times t, n is 2 times 8 for t. Close your parentheses. All right, so when in doubt, you can put parentheses around that exponent. And this gives us our overall amount, our accumulated amount. So $33,652.86. Typically, we're going to round these to 2 decimal places because they're dollar amounts. So typically, these problems will say round to 2 decimal places. All right, so I want to show you guys a shortcut before we keep going. So this is a calculator shortcut. We like those. So you can hit second and then the enter key. If you see above enter, it says entry. So what that's going to do is it's going to copy down exactly what you just typed in, and then you can make quick little edits if you need to. And this will save a lot of time for problems like this. So for example, we were typing into our calculator 25,000 times 1 plus 0.0375 over 2 raised to the power n times t, 2 times 8, which obviously is 16, right? So let's say we wanted to type in this calculation instead. If I hit second and enter, I can go back. And for my exponent here, I can type in 16. Oops, go over here. Let me delete what I had typed in already. And I'm going to replace that exponent. Instead of 2 times 8, I'm going to type 16. Obviously, that gives me the same exact dollar amount. So if you just want to make little edits to your previous calculation, this could come in handy. And remember to use the delete key, which is up there in the top center. Do not use the clear key, because then that'll just erase the whole calculation. So use delete if you want to scratch out some characters there. Okay, so part B. I'm going to calculate this accumulated amount compounded quarterly. So because I have quarterly compounding, I'm going to use n equals 4 instead of n equals 2. So in my calculator, I want to type in 25,000 times 1 plus 0.0375 over 4 instead of over 2. And then raised to the power n times t, that would be 4 times 8. Or you can, of course, type in a 32 there. All right, so I'm going to use that second enter shortcut. So going over here, so where it says 2, in your calculator, it probably lets you type straight over the 2 and just replace it with a 4. I have this little calculator app, so I'm going to have to delete my 2. And then I'll go ahead and delete, oops, put my parentheses back there. I want to delete my exponent of 16. You might be able to just type directly over it. So I have 0.0375 divided by 4. Now I want my exponent to be 4 times 8, or equivalently 32. So I'll go ahead and type the 32 there, hit enter. And this gives me my dollar amount of $33,699.34, rounded to 2 decimal places. All right, next up, compounded monthly for part C. Compounded monthly, I'm going to use n equals 12. So in my calculator, I want to type 25,000. Oops, wow, that was weird, zoomed in. 25,000 times 1 plus 0.0375 divided by 12, raised to the power n 12 times t, which is 8. I'll use second and enter just to save myself a little time. So down here it says 4. I'm going to delete that and replace it with 12. And then my exponent up here, I'm going to delete my 32. And suppose I don't know what 12 times 8 is. I'm going to put parentheses. I can always just type the calculation in with or without parentheses. In this calculator, it wouldn't matter because they're both in the exponent. But if you have an older calculator where it's showing the caret key on your screen, definitely put the parentheses around your exponent. All right, and this gives me my dollar amount, $33,730, and rounding to 2 decimal places, 69 cents. There we go. All right, so just looking at A, B, and C so far, notice that as we compound more times, semi-annually was n equals 2, then quarterly n equals 4, then monthly n equals 12. Notice that our dollar amount is going up, 33,652, 33,699, 33,730. So the more you compound per year, the more interest is accruing. Your credit card company, go ahead and take a look at your statement and see what the compounding is there. They typically compound monthly, so that cranks out a lot of interest. A really bad loan would be compounding daily. They really kill you with interest that way. All right, so last we have part D, compounding continuously. And that's when we bring in this other formula. So if you see continuous compounding, you're going to use a totally different formula. A equals P times E raised to the power RT. So we've got the same players. P is your principal. R is still your interest rate. T is still your time. And then we just have this new base of E, that irrational constant. All right, so we're going to type into our calculator, A equals P times E raised to the power RT. So in our calculator, we want this to say our principal of 25,000, base E raised to the power 0.0375 times 8. So let me clear all this out. I'm going to start from scratch here because it's a really different formula. 25,000 times E, so second and the ln key to pull your constant E up. And then it should put you in the exponent already, but if it didn't, you can use that caret key to get your cursor in the exponent. And then again, you can play it safe and use your parentheses. Why not? Doesn't hurt. 0.0375 times 8. Close your parentheses, hit enter. So this gives us $33,746.47.